Hello class. Today let's go over a few problems from section 2.6. It is about domain of the functions, and if we compose it to functions, then what will be the composite of those two functions. Now on exercise number 1 A, we don't have any restriction in this function, meaning we don't have any square root, we don't have any fraction. That's why for every value of x this expression makes sense. That's why domain is from negative infinity to infinity. No value we have to throw, because for every value it does make sense. Number B, it is a rational function. In mathematics we always have to be careful if we divide by 0. So the problem is, for what value of x square minus 49 is 0. We don't want that. So if you factorize, that will be x minus 7, x plus 7 equals 0. That gives x equals to 7 and negative 7. Meaning 7 and negative 7, those are the points, cannot be part of the domain because they make denominator 0. So let's throw this. Let's throw this. So we do have three pieces. The first piece we can write is negative infinity all the way to negative 7, not included, open parenthesis, union. For the middle piece, starting at negative 7 but not included, all the way to 7, not included. And for the last piece, starting at 7 but not included, all the way to infinity. For number C, we know if we have the radical sign, or technically square root, we don't want the expression under radical is negative. It should be always greater or equals 0. And we are kind of expert to solve this kind of inequalities. Add 27 on both sides, cancel out. So 9x is bigger than 27. Divide both sides by 9. So we got x is bigger or equals to 3. So 3 or more. So this is 3 or more, and 3 is included. That's why how we write 3 is included. So bracket and all the way to infinity. That's the final answer. Number D. We have to be careful on number D. It has radical, that is the first issue, and not only radical, it is on the bottom. So that means the expression under radical 4x minus 3x should be either bigger or equals to 0, but since it is on the bottom, it cannot be 0, so we should have strictly bigger than 0. That is the difference between number C and number D. So let's add 3x on both sides. 24 is bigger than 3x. Let's divide both sides by 3. So 8 is bigger than x. That means x is smaller. So there is 8 and x is smaller and 8 is not included. So how to write? We are hitting all the way to negative infinity and going all the way to 8, but 8 is not included. That's how we write domain of this function. Now here on exercise number 2, basically we should understand what is the meaning of this notation. Meaning of this notation is simply add f of x and g of x. So f of x is x minus 5, and then the g of x is x squared minus 1. If there are like terms, we always combine. X squared, x minus 5 minus 1 is negative 6. So that's the final answer. For this, meaning of this is we subtract g of x from f of x. So f of x is x minus 5. Subtracting g of it has more than one terms. That's why I need to put parentheses. So x minus 5, distribute negative sign. Negative x squared, negative times negative is positive 1. Now this is the point where we combine the like terms. Negative x squared plus x, negative 5 plus 1, that is negative 4. F times gx, meaning of this notation is we multiply f of x with g of x. Let me put this, multiply. So f of x is x minus 5, multiply with g of x is x squared minus 1. Since both are binomial, let's do the FOIL. X times x squared is x cubed, x times negative 1 is negative x, negative 5 times x squared is negative 5 x squared, negative 5 times negative 1 is positive 5. And combine the like terms if we have any. It seems we don't have any like terms, so let's write in the decreasing order. It is not necessary, but it is always nicer way to write. Number D, we are dividing f. Meaning of this notation is divide f of x by g of x. So f of x is x minus 5 divided by x squared minus 1. We cannot do anything here. That's why that is the final answer. Now here, f of x is that much and f plus g is given expression. So f of x plus g of x will be square root over x minus 3 plus square root over x plus 1, and they are not like terms, so we cannot combine. That's the final answer. But here the tricky part is the domain. Domain should be always common of both. So domain of f x is bigger than 3 or more. There is 3 included, and go right. And the domain of g is the way we did previous problem. X plus 1 should be bigger or equals to 0. If you do that, you will get negative 1. Negative 1 included, and go right. Now if you see what is the common domain between them, it seems the common part is starting at negative 3 and going right. So the interval is not negative 3, positive 3. Positive 3 included, going all the way to infinity. Just the common of both domains. Now here it is about the composite. F composite g of negative 1. Meaning of this expression is f g is acting first at negative 1. Now g of negative 1, that means we use function for g. That means we plug negative 1 here. If you plug negative 1 there, how much we will get? Let me do separately. 2 times negative 1 square minus x is negative 1 minus 1. So this is 2 plus 1 minus 1, so it becomes 2. So g of negative 1 is, the whole thing is 2. That means g is gone because the value we already got. So f of 2 is, now we use the function this. So let's plug 2 for x. So it becomes 16. For number B, meaning of this notation is g, f is acting at 1 first. Now separately, I'm going to use function f and plug 1 for x. 5 times 1 plus 6, so that is 11. So g of f1 is 11. Now we have to use function for g. 2 times 11 square minus 11 minus 1. 2 times 11 square is 121 minus 12. So this is 242. Subtracting 12. So it becomes 230. F composite gx. So F meaning is G is acting on X first. So F is there. G of X is how much? 2x square minus X minus 1. This is the new input. So we replace this new input for X in the given function F. So 5 X should be replaced by this expression 2x square minus X minus 1, 5x plus 6. That is the final answer. Now G composite fx meaning is G, F is acting on X first. So G, what is the value of f of x? Is 5x plus 6. Now 5x plus 6 is the new input for G. That means we replace x by 5x plus 6 in the expression of G. So 2x replaced by 5x plus 6, that x has power 2, minus x replaced by 5x plus 6, it has two terms, that's why I give parentheses, minus 1. That is the final answer. If you like, you can simplify. Now exercise number 5. F g of x, that is the meaning of that notation. If g of x is 1 over x, that means we replace x by 1 over x in f. For there is no x, divided by x is replaced by 1 over x plus 2. This is the final answer, but you can simplify a little bit more. So because here we do have x in the denominator, so let's make the common denominator. 4, x is the common denominator on the bottom, 1 plus 2x. 4 divided by a fraction, that means we multiply by the reciprocal, 1 plus 2x. So the expression becomes a little bit nicer, 4x divided by 1 plus 2x. Now it is talking about the domain. Now the domain, we have to be careful. Here we are using 1 over x. For what value it does not make sense. For x equals to 0, it does not make sense. That means we have to throw 0, because if you plug x equals to 0, that will be undefined. Now here, for what value of x, it is undefined. That means the bottom becomes negative half, isn't it? X equals to negative half. So we have to throw this also. Now on the number line, there is 0, we have to throw, and there is negative half, there is negative 1, and negative half we have to throw. So now let's write the domain. For whole this piece, we can write negative infinity to negative half, obviously not included. For the middle piece, union, negative half to 0, and for the rest of the interval, union 0 to infinity. That's how we find the domain. Now we did the composite in the previous problems. Now here let's decompose. It's already given the composition, what to function we can compose it, so that we end up with this. So obviously one function could be f of x equals to what? 3x minus 1. And another function could be like here you could have different answers, by the way. Power 4 is going x to the power 4. If you combine these two, you will get the functions given. Now the same story for b also. One is coming, excuse me, x square plus 5, and another function coming square root over x. So if we combine those two, you will get those kind of expressions.